Hello everyone, this is Saroj Tripathi. In this video, I'm going to talk about Direct Digital Control System. Direct Digital Control System is a building management system. It is a computerized system that gives ability to monitor and control various buildings equipment from one central location. It uses programmable computers or microprocessors that can perform logical tasks based on information received from in devices. So direct digital control systems works in basically three-step process. It receives signals from devices like sensors, and it processes the data based on the signals received from the sensors, and it makes the logical decisions and then send signals to equipments like HVAC system, lights, and other various mechanical equipments in the building, and basically says what to do. For example, if someone enters in the building, light sensor senses that there's someone in the building, it sends it to the controller, and then controller basically makes decisions to turn on the light, and then it tells light to turn on. So the entire process, how it works, and various components of DDC I'll talk about them throughout the video. But first, let's talk about the benefits of using DDC systems. So one of the benefit of using DDC system is it gives ability to monitor buildings equipment from one central location. We have graphical workstations like computers, laptop, any devices with graphical user interface. Gives ability to monitor our so basically gives ability to monitor the status of the equipments, how are they working, and the entire process. In most of the time, DDC systems can be accessed from remote locations. So facility personnel can be there watching it 24/7, watching the status, giving control to various building equipments, and all that good stuff. Likewise, the other advantage of using DDC system is quick and easier maintenance. So like we talked earlier, there can be someone watching over the building equipments 24/7, so they will know what's going on, and if the system is not working properly, they can just control the equipments from the remote location, or if it needs physical presence to maintain the equipments, they already know what's going on before they get the ticket or they get call from someone, so they can be on site to maintain the equipment. Another major benefit of using DDC system is it reduces the energy uses. It reduces the energy uses in a sense that we are able to control how we want to use our building equipments. For example, we don't want our lights to turn on 24/7 if there is no one in the building. So we can have controller controlling when to turn on the lights and when to turn off the lights. Likewise, you can have our HVAC system control from controller based on whether the building is occupied or not. So it really helps reduce the energy bill. It provides ability to schedule tasks for various building equipments. So DDC system allows us or facility personnel to schedule certain tasks, like the previous example that I gave about the light sensor. So that is kind of scheduling a task, like when to turn on the lights, when to turn off the lights. when to turn on the air conditioner, when to turn on the heater. So we can basically schedule a task for at a certain time. Another very useful benefit of DDC system would be it provides historical and real-time data. So everything that DDC sends from its sensors, it stores all that data in a storage. So there's two things. So facility personnel can monitor that data like in real time, or any managers or any person who wants to monitor what's going on in the building can go back and then open up a file and see all the details or data on the equipment's uses and make decisions for budgeting and all other operational activities. So now let's talk about the components of DDC system. So basically there are 5 components that makes of DDC system. That would be a computer terminal, a controller, software, server and router, points and sensors. I will talk about these components in detail in the following slides. So first let's talk about the computer terminal. A computer terminal is a computer that we use in our for our daily purposes. It has monitor, keyboard, mouse and processors. So basically computer terminal, or in other terms we can call it a workstation. It can be used to interact with the direct digital control system. And another one is controller. So this is the main part of the direct digital control system. So basically it takes data from the sensors, it makes the decisions and sends signals to the control devices. So all the stuff I talked about DDC earlier, so the controller makes it possible to make a complete direct digital control system for the building. Likewise, we have software. Software is nothing but lines of code that helps operate the controller hardware. So, excuse me. So software tells the hardware what to do. So software are a written code. So basically pre-programmed decisions on what to do when it receives signals from the sensors. Servers are also computers, but with high-end processors and large storage. So servers stores all the data that are received from the sensors or other DDC components and makes it accessible for future purpose. And then we have router. Router is a device that interconnects all the DDC components, like controller, software, server, and computer terminals. So router is basically router facilitates in the communication between all these components in DDC system. Then we have points. Points are nothing but the unique identification or addressing representing data within DDC systems. So we talk about how we can store all the data in our servers, right? So points, let's say those data are from different systems, like different sensors and different equipments. So each data are uniquely identified using points, so that we can go back and then reference that point. It can be name, number, anything. Then we can have the information that we needed for a specific device or sensors or the specific data we wanted. Now we have sensors. So sensors are devices that measures or senses changes such as light, heat, sounds, humidity in item or medium. So that's equipment. So basically it measures changes in our environmental variables. Sensors sense. So basically, the input for the sensor would be the changes in light, heat, sound, and humidity, and the output would be the signal, like hey, so there's a low light, there's no light, there's a high heat, there's low heat. Then that signal would be sent to the controller, and then for the controller, that signal would be its input. And there are different types of sensors. We have quality sensors that measures space temperature, humidity, carbon dioxide, ambient light, and there are safety sensors that measures presence of smoke, air flow, water flow, low voltage, and there are operational sensors that measures data such as pressures, equipment status, and so on. So how do all these DDC components talk to each other? In other sense, what language do they use? So that's where the control protocol comes in. So control protocol is just another computer language used in DDC system. So protocols are set of rules or standards that helps DDC components to communicate with each other on the network. Let's say we have two people speaking two different languages, but they need to communicate. And then how do they communicate? They use a common language. The popular one, English. So both of them might know English language, so they will talk in English language. Just like that, these DDC components have a set of standards or rules or a common language that they will use to communicate to each other on the network. There are two different types of control protocols. There are open protocol and proprietary protocols. So open protocols are free to use. Any manufacturer can use those protocols in their devices, so that whatever devices they manufacture can talk to each other. It doesn't require any additional hardware. Some of the examples are BACnet and GLONWORKS. So we can use these two protocols even if we want to make some DDC system on our own. Then there is a proprietary control protocol. So proprietary protocols are basically designed by a manufacturer. Those devices will only be able to talk to each other that has or that are installed with these proprietary protocols. So we cannot use those proprietary protocols to make our own direct digital control system. And that's it for the direct digital control system. Thank you.